No. Okay, so this is geometry. Your quarterfinal would be 1 through 45. Test review part 2. I actually want to pick it back up with question number 3. You're going to get something similar to this. It's going to give you a triangle. It's going to ask you to classify it by its sides and its angles. So just real quick, I mean, we should be able to see this and see isosceles acute, but what other types of options could exist for classifying a triangle by its sides? Okay, if we're just talking about side classification, we have isosceles. What else do we have? Scalene. What does it mean for a triangle to be scalene? No equal sides. So, I mean, we can get different types of scalene. We can get acute scalene. We can get obtuse scalene. We can even get right scalene. So, although we typically see scalene kind of, be something like that, obtuse scalene is kind of the most popular. All right, don't think that we can't get scalene in different types of angle scenarios. Okay. All right, did I say? Yeah, I said acute, obtuse, and right scalene. Okay. What else could we get? Equilateral. Okay. Equilateral. An equilateral is always going to go with a specific angle option, right? We can't get an equilateral right triangle, okay, because the hypotenuse is always the longest side, so it has to be longer. So we wind up with these three in terms of side lengths. And of course, an equilateral triangle is going to have 3 tick marks all the way around, right? Okay? All right. And of course, we know what acute is. Acute means all the angles are what? Less than 90 degrees. Okay, which means we do have a 90-degree option, which we call what? Right. But it's only right if it has what? Let me ask you real quick. Is this a right triangle? No. Good. Why not? Doesn't have the box. So this could be 89.999 degrees, right? Until I put this in, and that tells me it's exactly 90, no more, no less. Okay? So don't get fooled by something that looks right, but isn't expressly stated that way. So we have right, and what else do we have? Obtuse. Okay? All right? And they're going to be pretty nice to you. If they're going to show you an obtuse triangle, it's going to be something that's clearly obtuse. Okay? They're not going to show you what looks like a right triangle but without the box, and so you can't tell if it's acute or obtuse. They're not going to probably do that for you. Okay, so we understand what's expected, and we've kind of hit everything that we need there. All right. They're going to give us another polygon, and it doesn't have to be regular. It could be, let's just make, let's call this what, question 4. Okay. How would we classify that polygon? Yeah, you would be correct in calling it irregular, but just like the question that we had on the board where we had a shape inside of a circle, when I ask you to classify it, right, it's not just regular, irregular, but in that case it was a quadrilateral, so we classified it by its number of sides, right? So this is going to ask you to classify this based upon its number of sides. So I know that you don't exactly get to draw on the test because it's a computer test, but if you could, I'd go 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. So what do we call that? 13-agon. Okay? What's the minimum number of sides a polygon can have? 3, because I can't get a closed figure with 2 sides. What do we call a 3-sided polygon? Triangle. What about if it's got 4 sides? Quadrilateral. Okay, what about 5 sides? Pentagon. Okay, 6? Hexagon, good. 7? Heptagon, good. 8 sides. Octagon. 9 sides. Nonagon. 10 sides? $11 sides. I believe 12 is dodecagon. I believe 11 is hendecagon. Okay, and then dodecagon. Okay, and then everything after that is whatever the number is, agon. Okay, so just, you want to count the sides and you want to keep these names in mind. Okay. All right. Let's see, number 5. Number 5. It's going to give you a statement or a definition, and it wants you to write it as a biconditional. What does a biconditional have in its statement form? Anybody remember? Sure, hypothesis and conclusion, but it has a specific set of words. Go ahead. If what? Oh, if then. No, not in this case. Now it does have if and only if. And where does it exist? Is that at the beginning? Is it at the end or the middle? Okay. If and only if. Okay. Now we only use if and only if the statement is true and the converse is true, meaning that whenever I flip the hypothesis and conclusion, it's still true. So what if we said an obtuse angle is an angle whose measure is greater than 90 degrees? Okay? An obtuse angle is an angle whose measure is greater than 90 degrees. How could I turn that information into a biconditional statement? Close. I wouldn't start off by saying an obtuse angle is an angle, because, but maybe an angle is obtuse, if and only if. Does that make more sense? Okay, so an angle is obtuse if and only if what? Its measure is what? Greater than 90 degrees. Okay, do we see how to put that together? Okay, now I'm telling you that that's not the statement that they're going to use on the test. It'd be something similar to it but different. Okay, so you need to look first for if and only if, and then you need to make sure that it's correctly worded. Okay? All right. All right, 6. All right. 6, you've seen this before. You're going to see 2 parallel lines cut by a transversal. Actually, you're going to see 2 lines anyway, cut by a transversal. And it's going to say which 2 angles, if congruent, prove that the 2 lines are parallel. Okay? Now, it's going to give you some options to pick from, but let's say, this is line A, this is line B, this is line T. Okay? Let's see some pairs of angles. If congruent, would prove that those lines A and B are parallel to each other. Can anybody tell me 2 angles, if they are congruent, would prove that those 2 lines are parallel? 6 and 2. Okay? You're right. Can you tell me why? Nope. Okay, the second word that you were using, what was that word? They're corresponding angles. Okay, so this would be true via the converse of the corresponding angles postulate. Okay? Meaning that because those angles are congruent, those two lines are parallel. Are there any other corresponding angles in here? What? 1 and 5? 1 and 5? 4 and 8? Good. And 3 and 7? Good. Okay? Is that it? Nope. 1 and 8. Good. Angle 1 and angle 8. What's special about 1 and 8? What are they? Alternate? Nope. Alternate exterior angles. 1 and 8 are alternate exterior angles. Are the 2 and 7 are alternate exterior angles. Is that all my alternate exterior angles? Okay. Are there any other types of congruent pairs we can make? What's that? Those aren't congruent. Same side interior angle, but if they're supplementary. Okay. So I think I heard you say alternate interior. All right. So alternate interior angles. What are my alternate interior angle pairs? 4 and 5, angle 4 and angle 5, angle 3 and angle 6. All right. What about angle 2 and angle 8? Is that anything? Angle 2 and angle 8, is that anything? I'm telling you that these are the only 3 types that will work. There's no such thing as same side exterior angles being congruent. Okay? What about, what about 1 and 6? Are those anything? 1 and 6? Can I make anything out of that? 1 and 6? Zach, what do you think? 1 and 6? No? What about 2 and 3? They're congruent, aren't they? They're vertical angles. Can I use those to prove that those two lines are parallel? No, because neither of them touch line B. Okay? So what you have here are the only 3 categories that will work. So when you're given this question on the test, they're going to give you 4 or 5 possibilities. Only one of them is going to fit into one of these 3 categories. Okay? There won't be more than, you'll get vertical angles, you'll get some weird things that aren't corresponding alternate exterior or alternate interior. So if you find yourself making same side exterior, same side interior, alternate, I don't know, where you've got 4 and 7, which are nothing, right? You keep finding, you put together some nothing angles, you're going to be wrong, okay? So hopefully we remember some lesson 12 stuff, okay? All right, question number 7. Okay, here we want a counterexample. Let's see if we can come up with a counterexample. If x squared equals 49, then x equals 7. Is there any counterexample that we can come up with? X equals -7 is a counterexample. Does -7 squared equal 49? Yes, but is -7 equal to 7? No, so it's got to be true according to the hypothesis. It's got to be something I can plug in for x and square it and get 49, but is not equal to 7. Yes. It's got to be true hypothesis, false conclusion in order to have a counterexample. Okay? All right, 8. Which statement? Here they're asking for something that has a true converse. Okay, so what is a converse of a statement? If my original statement is if A, then B, what's the converse? If B, then A. So what I need to do for this is that they're going to give you, they're going to give you 4 different statements. You need to write the converse of each of them until you find one that when you have a converse, it's true. Okay, you're not looking for a statement that's necessarily true by itself, but whenever I write the converse is true. Does that make sense? All right, I'm not going to go through a whole list for you, okay? Because they're all going to be different statements. You follow me? Okay. All right. We'll stop right there.